All right. So the definition of the problem can say one of two things. It can say find the zeros. It can say solve. Okay, if it says solve, it's no different than quadratics. It's asking you to find the values which are zeros, so therefore it'd be setting this equal to 0 for us to find it. And if it asks us to do something with the graphing, I need to find the zeros to be able to do so. Okay, so we're going to take care of a couple of things that's not really asked in this problem. Okay, so we can knock out this whole graphing thing. So the first thing that I'm going to do is I'm going to go to the graph. I'm going to go to the graph, and so we can graph this equation. Okay? And so therefore, I'm going to put it in as x cubed plus 5x squared minus 6x minus 30. Okay? And so we're going to graph it. I'm going to hit graph, and as you can see, it's going to generate a cubic graph. And what does it look like to you? What does it look like? Now think about what I'm asking you. Am I asking you to tell me the design of the graph? I'm asking you to tell me what it looks like in association to what I'm asking you to solve, which is the zeros. So what does it look like?
It has 3 zeros.
It looks like it has 3 zeros.
Boom.
Okay, it looks like we got 3 zeros. Okay, and so I'm going to zoom out just a second because I want to talk about something here I want you to do. I hit the wrong button. We're going to zoom out. All right, see what those humps are on it right there. Okay, how many we got? We got 2 of them. What's the end behavior of this look like? Down to up. Down to up. Correct, so it's a positive graph. We knew that without the end behaviors because the leading coefficient is positive. Right? And so therefore, could you find the maximums of those? The maximums and the minimums of those humps on the graph? Do you remember how to do so? Okay, so let's do that real fast, just to be an extra thing that you'll have to find. So we'll go second calc, scroll down to right here to, if I'm finding the first one, is that going to be a max or a min? Okay, look at the graph a second. It's going to be a max if I'm finding the first one. So I'm going to go second calc, I'm going to scroll down to max, and then it's going to find the maximum between it. So I got to scroll to where my blinky thing is there, and over the maximum to there. And what maximum do you see? Is the max defined by the x value? Is the max defined by the x value on yours? No, it's defined by the y value. And what you can do is you can see that the y value there, come on, focus. There it is. The y value there is 10 point something, so that maximum right there, relative maximum, is going to be 10. So how do I find the other one? Is it going to be a maximum or a minimum? Minimum. So I go second calc, we're going to find a minimum, and the minimum is going to be located down here at the bottom one, so I got to have my blinky thing on one side and on the other side. And what does it look like the minimum is on that one? Negative 31 and some change, right? And so therefore we can find maximum minimums of those humps that we have. Everybody good with that? All right. So now then, let's go back to our zoom, and we're going to zoom at standard, and now we're going to talk about finding the zeros. Okay, so here's my graph. We see that I have 3 of them, and as I look at them, do any of them look like they come exactly out on a tick mark? As I'm looking at my graph. What about this one right here? That one right there looks like it comes exactly out, and the other ones over here looks like they're in between them on it. You agree with that? Now, thing about it is I only need one of them. Okay, so I'm going to go to my table. Okay, and so I go to where the y value is 0, and my x value at that y value is 0 is what? Negative 5. And so I'm going to utilize that, negative 5, as my x equals negative 5. What's the factored form of that x equals negative 5? What would be the factored form of that if I wrote it in factored form? There you go. X plus 5 and equal to 0 would help me find that 0. And that's important because what I want you to see to find the zeros, we are factoring the equation. Okay? We're factoring the equation. All right, so now then, I have one of the zeros, so therefore I'm going to use that one to help factor out the other. And I'm going to use synthetic division because once I wrote it as x plus 5, I wrote it as a linear equation. And when I have a polynomial divided by a linear, I can use synthetic division to do so. Now, why do I write it as negative 5 in my box? Anybody remember from yesterday why we write it as negative 5?
Because it's the opposite of 5, and it cancels it out.
It doesn't because it cancels it out. Because it's what's going to create the 0, right? The 0 is at negative 5, and so you would be given that. And what's going to make that 0? Negative 5 going into it would make it 0, or set that equal to 0 and subtract 5 from both sides. So we don't just say, oh, we're going to flip the sign. That's not mathematically correct. We have a reason why we're flipping the sign. Okay? Now then, so we're going to bring down the coefficients. My coefficient here is 1. My coefficient here is 5. My coefficient here is negative 6. My coefficient here is negative 30. Everybody agree with my steps so far? Okay? And so right here is going to be my remainder that's going to happen if I have one. Okay? And so I bring this one down, bring the coefficient of 1 down. I go negative 5 times 1 gives me negative 5. And that's going to be 0. Negative 5 times 0. It's going to be 0. 6. Negative 6 plus 0 is? Negative 6. And then negative 5 times negative 6 is? Negative 30.
That's positive.
Positive 30. That's what I said. And 0 is my remainder. And so what do these tell us right here? What do those tell us? What did we just do? Why did we just do this synthetic division concept? What we did is we divided a polynomial by the linear, and so we reduced this down by at least 1 power on my x. And so if my leading power was x cubed, this is going to become
X squared.
X squared.
Minus 6.
Okay, this is going to be plus x to the 0 minus 6, and obviously we know that this is going to turn into x squared minus 6. And so really what I have is I have a factored form of x plus 5, x squared minus 6. If I multiply that out through polynomial multiplication, I'm going to get my original equation right up there. Okay? And that's really what you're doing. When you factor, you're dividing. Okay? Now, so I've got to solve that one of my zeros is negative 5. We could see that one. And my other one's going to come from this right here. So I got to set this equal to 0. And the reason why we want to get it to an x squared is because we just spent a whole section of quadratics solving x squareds for 0. So we could use factoring, we can use quadratic formula, we could use the table, we could use the zeros feature of my calculator, and we could make it work out. Okay? And so what I get right here is I'm going to add 6 to both sides. That's going to give me x squared equal to 6. How do I solve for that x squared? Square root on both sides, so that x is going to equal, okay, and it's the plus or minus the square root of 6. Okay? And that's a decimal. Okay? That's a decimal. Now, let's go back to my calculator a second. Okay, really quick, we're going to finish this out. Okay? If I go to my graph, we notice that this 0 right here and that 0 right there are not on one of the tick marks. They're not a whole number. Do you agree? Do you also see that they look like that they're symmetrical between them? Like this axis is the axis of symmetry? It is the axis of symmetry if this right here was my quadratic graph. Okay? And so therefore this one and this one are going to be the same values except opposite sides of each other. And so I can also go to my calculator and I can calculate the 0 Okay, let's see where my cursor is. There's my cursor. Okay, so let's find this 0 over here first. I'm scrolling. There it is. So I'll put it there. I'll scroll down below it. Find that 0, and it's going to come out to be negative 2.44949, and it's going to continue going. Okay? It's an irrational number. All right? And so that's also the same thing. If you went in and you took the square root of 6, that would be the negative version of that. All right? So I can also find the 0 on the other side by scrolling with my little cursor. I'm going to find the 0, come on guy, there you are, from there, and I'm going to put that piece in the middle to there, and I'm going to come out with a positive 2.449, and as you see, it doesn't stay 4949494949. Okay? And so they're irrational. It changes. But those are my values of the positive of 6 and the negative of the square root of 6. And that's how I can find the zeros of that graph.